In this module, we're going to look at how to solve a new type of inequality. You see a few of them here, along with some of the inequalities you already know how to solve. Let's review some of the ones we've seen before. First, there were linear inequalities in one variable, like this. The solution? Just move terms to get a single x all by itself. After that, there were two-variable problems. To solve these, we start by drawing the straight line in the middle and then shade the correct side for our inequality. More recently, we had inequalities with absolute values like this, and we solved them without any particular difficulty. But if any of these three types of inequality gives you trouble, remember there's a separate module on each type, so look it up and check it out. Now we're going to check out inequalities with squares, or with higher powers. Just as we see in these absolute value problems, our answers will turn out to be intervals on the number line, sometimes in two parts. But we're going to use a different method in solving the inequalities now. If you were to look at the left-hand side of this inequality, you'd probably say, gee, I should factor that. And you'd be right. So we do it. And notice that we're dealing with something greater than 0 here. That's positive. Now let's go back and extend an idea we used in quadratic equations. It went like this. When we have two things multiplied together with answer 0, then one of the two things has to be 0 also. Now in our present problem, we have a product where the answer is greater than 0, positive. That tells us that one of two things has happened. Either both of the brackets are positive, or both of the brackets are negative. Next step, we take a careful look at when each bracket can be positive or negative. And then we draw a picture that shows the answer on the number line. Here the number line shows the first bracket, x minus 5. Then we do the same thing for the other bracket, x plus 4. The picture shows which values of x will make x plus 4 positive and which values will make it negative. Then we put all of that together in one picture and look at it very closely. What does it tell us? Remember, we wanted to know where both brackets were positive and where both were negative. One look at the graph tells us exactly that. So our answer is that we need x values bigger than 5 or smaller than negative 4. And notice that at the same time we've automatically worked out the answer to the opposite inequality. Now we're dealing with less than 0, a negative number. To fulfill that inequality and get a negative answer, we need one positive and one negative bracket. But one look at our graph tells us that we've already worked out that information. The interval in the center has just what we need, a positive and a negative. So our answer this time is that x has to lie between negative 4 and positive 5. All of which means that our two problems taken together split the real line into three intervals, just like absolute value inequalities. And now it's your turn. Here's the inequality. What's going to be your first step in solving it? Rearrangement. You need 0 by itself over on the right side before you factor. Then you'll want to factor, and then draw a picture of the positive and negative signs for each factor. Come back with your answer and we'll check it. First of all, I factor and get these two brackets with a product which is negative or 0. So I know my two factors have to have opposite signs. I draw my number line and show the intervals where each of the brackets is positive and negative. What I need is one of each, so I choose that interval in the middle which has one of each. And I find that my answer is that x can lie between negative 3 and positive 4. Our answer includes equality this time because the original problem contained equal signs. That's really all there is to this technique. It all depends on thinking about positive and negative. But there are still a couple of small complications you might run into, like what if it doesn't factor? Well, what have we been doing when it didn't factor? Right, we've been using the quadratic formula. That will give us the numbers where we change from positive to negative. And that's just what we need to draw our picture as usual. We get the same pattern with the different signs in the middle and the same signs at each end. Notice that our product is positive here, equal to or greater than 0. So we're going to want the two ends of the number line. Don't worry about the awkward numbers, that's just what happened to come out of the quadratic formula. Here's another sort of complication you might run into. Usually, when we have fractions, we multiply to get rid of them. Can we multiply here? Well, we might, but when you multiply an inequality by something negative, the inequality sign changes. When you multiply by something positive, it doesn't. So we need two separate cases depending on whether x minus 5 is positive or negative. That's awkward. Question: will it work if we copy the method we just learned? The answer? Well, this time we have 3 brackets multiplied or divided, and we want the answer to be negative or 0. There are 2 different ways that could happen. Either all 3 brackets are negative, or only one is. That tells us what we're going to look for in our picture, but we have to draw it first. Only this time we have 3 separate brackets, and signs for each bracket separately. As usual, our intervals split where each bracket is 0. The split between positive and negative occurs at a different spot for each bracket. And now we check for the two combinations that will give us our negative answer. All three negative, or two positive, one negative. And immediately we can read that x must be smaller than -2, or between 3 and 5. What about the endpoints? Watch carefully. We can include -2 and +3 because of the equals sign in the original inequality. But we can't include 5 because it would make the denominator 0. So we've seen that this approach will work for 3 brackets. But actually we can use the same method for as many brackets as we like, as long as they're multiplied or divided. And that does it for quadratic inequalities. Be sure to practice on some more problems from your textbook right away. And good luck.